Hey everyone, this is Mr. Mull. I'd like to give you one more shot at seeing these multi-dimensional conversion problems. This is when we're dealing with two different units at one time. So I was just going to do a sample problem from the homework again and show you the full solution. Both ways you can do it, and you can choose whichever way you'd like. Okay. So for these types of problems, they are characterized by two different dimensions. In this case, we're talking about meters per second, and we're converting that to yards per hour. So I have two dimensions for this problem. I have meters, which is the unit of length, and seconds, which is the unit of time. Okay, so we're going to have kind of two conversion problems going on at once. So what I want you to do is I want you to take this first number, and I want you to kind of rewrite it. So I'm going to go ahead and do that first. 75.0. Now meters is on top, but that per second, okay, that per second, I want you to think of this as that second being in the denominator. So I'm going to write this number over 1 like I normally do, but that unit of seconds is going to be hanging out down there. Okay. So 75 meters per second, this is another way to write it. This is going to be more useful, so we're going to do it this way. So then I have to do a conversion problem. Okay, we need to use some kind of bubble and set up some kind of conversion. So what I'd like to do is you could maybe make a map if the problem is complicated. Never a bad place to start. You also need to figure out what conversion factors you're going to need for the problem. So I like to break the problem into two steps, the top and the bottom. The top and the bottom. Now on the top, what you can do is you can go from meters, and that was our unit on top, and we want to eventually get our meters into a unit of yards. Okay, so there's my yards over here. On the bottom is seconds, which I need to end up converting to hours. Okay, you convert to hours. Now you may have more than one way to go. So I'm just going to look at my conversion sheet for units of length, and I find on there that there is a direct relationship. You can go from meters directly to yards. The conversion is in 1 meter is equal to 1.094 yards. So I just get that from my conversion sheet. Very nice, and I can plug that in. I can do that in one step. Seconds to hours, I can also do this in one step because I know that 1 hour is equal to 3,600 seconds. I could get that off the sheet too. Now if you had to, this problem's kind of simple, but if you had to, you could add as many intermediate steps as you needed to get from meters to yards. In this case, I only need 1, so this is nice. So what I want to do is I'm going to do it first. I'm going to do it dimensional analysis way, where we just make sure that the units left standing are the units we want to get to. So at the very end of this problem, I need to get yards per hour, and I need my units to have those, my answer to have those units. So we're going to use some dimensional analysis to get our units to cancel out in a way that we want. So I'm going to go ahead and go from meters, and I want to get yards on top at the very end. So I'm going to go ahead and put yards on top. I'm going to let the units be my guide. I need to get rid of meters. So if I cancel out meters, now I need to put the converter, the relationship between these two. So 1 meter is equal to 1.094 yards. Okay, so once I've done that, I'm now at yards at the top. That's nice, but seconds is still on the bottom, and I need hours on the bottom. So what I'm going to do is I'm going to use my other relationship and do another conversion bubble. And now we need to get into hours on the bottom. Now here's the thing. When I write this conversion factor, hours must be on the bottom because I need it on the bottom over here. So I'm going to put hours on the bottom, and that means I need to put seconds on the top. And when you look back here and I see seconds on the bottom in my starting quantity, it's nice because now those seconds can actually cancel, leaving me with hours on the bottom, which is what I want. So I'm going to go ahead and type in 1 hour is 3,600 seconds, and my hours are left on bottoms. My units standing are yards and hours, which are what I want. And now what I can do is I can punch this in my calculator. 75 divided by 1 times 1.94 divided by 1 times 3,600 divided by 1 equals, and then we'll get our final answer of 2.95 times 10 to the fifth. After I put it in the scientific notation, my final units will be yards per hour. Will be my final unit on there. That's one way to do the problem. Now I want to actually show you the different way. I'm going to go ahead and clear everything out and show you another way to do the same problem. If you'd like, you can totally do it this way. Okay, so I'm going to go ahead and clear this all out. And the other way we could do it is we could go 75.0 meters for every 1 second. And what we could do is we could actually have two conversion problems. On the top, we need to get to yards. On the bottom, we need to get to hours. You can actually address these separately, and then you can divide at the end. So what this would look like is meters to yards. I could do that conversion right here. And remember, we said that 1 meter was equal to 1.094 yards. My units would cancel, and I would get an answer of, I don't know what that will be. I'll get my calculator in a second. The second one, I could do seconds to hours. So I could do 1 second times, let's get that to hours. There are, let's get the units, 3,600 seconds in 1 hour. So now the bottom is kind of its own separate little thing. Seconds go away. We're left with hours. And what I'm going to do is I'm going to get two numbers here. So if I punch that in my calculator, 75.0, give me 1 second. Okay, thank you for your patience. I want to make sure that you can do this along with me. 75 times 1.094, we'll get 82.05. We're going to round it to 3 sig figs. 82.1 yards. And then on the bottom, 1 divided by 3,600 is going to give me a very small number, 2.77 times 10 to the negative fourth. So I'm just going to round that to 3 times 10 to the negative fourth. I would actually recommend, if you do it this way, to not round until the very end and just keep track of your sig figs, because there's going to be a lot of room for error on here. So this is actually going to be, let me put, this would be 2.7, we'll say 8 times 10 to the negative fourth. I don't want to get too fancy with the rounding, especially for the 1 second, because that's not even a measured value. So when I divide these two numbers out, 82.1 divided by 3 second e to the negative fifth, I'm going to get a giant number. Now the answer is going to be a little bit different than mine. When I punch that in with all that rounding, even though it didn't seem like much, I actually get 2.74 times 10 to the fifth yards per hour. So a good advice is when you're doing these multi-dimensional problems is to not round things until the very end. But if you, so maybe keep a lot of those numbers in your calculator, otherwise your answer is going to be way off. But you can totally do it this way, and I hope that this was helpful.